the last video, we had a look at the screw tool, but there also exists a screw modifier. In general, tools create changes that cannot be reversed at a later date, whereas modifiers can be instantly removed to return to the original geometry. But in the case of the screw modifier, it also operates in a slightly different way from the screw tool. The screw modifier can be used not only as an alternative to the screw tool, but also to the spin tool. The spin tool was covered in video 50. To demonstrate how to use the modifier in spin mode, we'll start by reducing a plane to a single vertex, and then create the basic profile of a goblet. Returning to object mode, we'll apply the screw modifier. This spins our set of edges to create our goblet. Only some of the parameter fields in the modifier panel are relevant when we are doing a simple spin operation. Angle defines the angle of rotation. If we set it to less than 360, we get a cut-through of our goblet. Axis defines which of the object's own axis rotation is about. By default, it's Z, but using other axes gives us different shapes. Steps sets the number of faces created in the rotation. This is independent of the angle setting. Separate values are used for the viewport and the final render. By selecting the Merge checkbox, adjacent vertices are merge. If we've rotated a full 360 degrees, the final set of vertices will overlap those in the starting position. The field connected to the checkbox specifies how close vertices must be to each other before being merged. Expanding the normals area, the checkboxes here affect the visuals of our shape. Smooth shading is checked automatically. Calculate order. This makes sure the normals and shading are optimal, but for the most part, this option won't be required. Flip swaps front and back faces. We may want to do this to ensure that the front faces are on the surface of the object. If we don't like the overall shape, we can return to Edit mode and adjust the position of the vertices, or even add more by using the Subdivide option. Next, let's see how we might create a spring using this modifier, since the technique is somewhat different from how we achieved the result using the screw tool. First, we'll start with a circle and scale it down. Since we want the spring to form around the Z-axis, we'll rotate it about the X-axis. When we used the screw tool, rotation was about the 3D cursor's axis, but here that rotation is about the object's local axis. To show that axis set, we need to first press N to display the sidebar, then, on the Tools page, expand Options, then Transforms and select only Origins. Notice that the local Z-axis is not aligned with the global Z-axis, and that is because we rotated the circle. This is easily fixed by choosing Object, Apply, and All Transforms. By pressing G, then X, we can use the mouse to move the circle's origin. Assuming we won't want to adjust the position of the circle's origin again, we can uncheck Select Only Origins and hide the sidebar. Now we are ready to add the screw modifier. By default, we get a torus centered on the new position of the original circle's origin. To create a rising shape, we need to specify the vertical distance we want the shape to move by the time the full revolution is complete, and this is done in the Screw field. Iterations specifies how many revolutions we want. If we apply the modifier, the mesh changes from the original circle to our spring shape, and we can enclose the ends of the spring if required by selecting each ring of vertices in turn and pressing F. Before finishing, we need to check that the spring's front faces are on the surface of our mesh. Unfortunately, we can see from their bright red color that they are not. But this is easily fixed by going to the Mesh menu, selecting Normals, and then Recalculate Outside. Only one part remains to be explained in the Modifier panel. Axis Object allows us to use the origin of another object in our scene as the center of rotation. Typically, we would use an empty for this purpose. We can select the object to be used from the drop-down list or by using the eyedropper. And if we check Object Screw, the controlling object's position along the axis of rotation controls the rise produced by each full rotation, replacing the value in screw.